Welcome to very first video of our series exploring the marvels of ancient Indian mathematics with the art of programming. So as this is our very first video, let us start with an overview. India is known to be the birthplace of modern mathematics. Even one of the most magnificent, awesome architectures like Konark Sun Temple, which were India's gift to world heritage, had an extensive use of mathematics in its construction. In this series, we will be exploring the algorithmic and computational nature of ancient Indian mathematics. This video is dedicated to one of the greatest mathematician Narayan Pandit's Ganita Kaumudi, written in 1356. Its translated version is also available by Parmanand Singh Ji. So let us have a glimpse of what the book have to offer us. So in the very first chapter, the book teaches things like basic measurement, basic arithmetic, solutions of various types of equations. In next chapter, it moves on to Vyavhara Ganit. So it deals with everyday mathematics. In third chapters, there we learn various type of progressions like AP, GP, infinite series, sine and cosine series. We will be discussing about all these in our upcoming videos. So in the fourth chapter, the book moves on to plane geometry, where you will get in-depth explanation about the cyclic quadrilaterals, and then comes the chapters from 5 to 8, where you will get a detailed explanation about the 3D geometry, and then chapter 9 to 10 you will get to learn about linear and quadratic indeterminate equations. In chapter 11 to 12, you will be getting a good explanation about the divisors and fractions, and then in 13th chapter, you will get explanation about combinatorics. So this chapter gives you a rule to determine the number of permutation of n objects and the classical algorithm for finding the next permutation in lexicographic ordering through computational methods. Donald Knuth describes this permutation generation and discussed this history in his book The Art of Computer Programming. And then the chapter 14 comes, where you will learn about magic squares. Ganita Kaumudi contains about 475 verses of rules and 395 verses of examples. It is divided into 14 chapters. This video is dedicated to Rūpādyaṃśāvatāra, which contains rules for writing a fraction as a sum of unit fractions, 22 rules and 14 examples. Unit fractions were known in Indian mathematics since the Vedic period. The Sulabh Sutras give an approximation of root 2. Ganita Kaumudi gave a few more rules for it. The section Bhagajati in the 12th chapter contain 8 rules. So there are total 8 rules, and in this video we are going to verify the very first rule with the help of a C program. So as usual, we will be including the library, we will create a main function, and to store the value from the user, we will create a variable. Observe the series pattern carefully. Observe the denominator. One value is kept fixed and other one is increased by 1. So with this logic, we will create n equal to I plus 1 into I, and we will keep this into a loop. and loop will go on from I equal to 1 to I less than k, not I less than equal to k. So what if equal to k? The last term we will get as 1 upon n square, which we don't want here. We will initialize s variable from 0. Assume that s is a bucket which is empty. Since we have initialized the s variable from 0, then every one iteration, one new value will be added to s. Like as shown here, with the very first iteration, 1 by 2 will be added. In next iteration, 1 by 6 will be added into that same pot. And this is why we do s equal to s plus 1 by n. Let us execute the code and see what happens. So we have got 0 here, which we did not want it. So what's the problem here? So we have declared the variables in the integer type. So on using division operator on integer, we get only the integer value, and that is why we have got 0 here, because the value which we are getting here, this final s variable, is between 0 to 1. And then now, to correct our previous error, we will change the integer type to float type, because with this we can get the answer in the decimal places also. So, but still we have not got the exact value for input value 5. We are still getting 0.8. So how we will be correcting it? Just observe the loop. We have input the variable from I equal to 1 to I less than k, not I less than equal to k. So we have omitted the last term. And to correct this, so now to correct this, when the loop gets over, when we will get the final s value from it, we will add 1 upon k to it. That is the last term. And finally, we will use printf and get our final answer 1. You can input any number for it, but you are going to get 1 only. So with this we have successfully verified the rules from Ganita Kaumudi.